So welcome to our first video. This is an introduction to algebra. We just need to go over some important language that we're going to use if we are going to understand math. Okay, so the first term I want to go over is variable. Okay, so variable is a letter or letters that may be replaced. Instead of saying replaced, we often say in mathematics substituted by numbers. Okay, so some examples of variables are a, x squared is a variable being squared. You can use other letters in our alphabet. We can use B as a variable, Y as a variable, Z. We can use basically any letter can be used as a kind of a placeholder for another number. Okay, and that's why we call it a variable. Constant. So a constant is a number that always has the same value. So think of it just a number. So 8 is a number. It's a constant. Fractions can be constants, so 1/2 is a constant. 5, -5, so negative numbers can be constants. You can have double-digit numbers, so -10. You can have huge numbers, 156. So basically, a number is a constant. It's not changing. It's always going to be that number. Terms. So terms are very important. Okay, terms a term is each part of an expression. Okay, so you're given a mathematical expression. Okay, like think of a sentence, okay, but we call it an expression, separated by a plus or minus sign. So each term is separated by a plus or a minus sign. So in this example here, 2x minus 9, we have two terms here. 2x is a term, and 9 is a term, and they're being separated by that minus sign, 2x minus 9. My next example here, I have 7x, which is a term, 5y, and 6. So these are three terms being separated by a plus for the first one here, and a minus sign for the next one here. Numerical coefficients. So numerical coefficients. So these are the numbers that are multiplied with each variable. So I have 32a. This is a term. Okay, it has a variable a, and it has a numerical coefficient in front of it, 32. So 32 is that numerical coefficient, and they're just constants. 32 is a constant. It's in front of the a, so we call it a coefficient. Okay. So remember this one thing though. Coefficients are always in front. So 32a, or well, let's just say 32 has to be before the a. Okay, you don't write terms like a20. You don't write terms like a32. No. Okay, it has the coefficient comes in front or before the a. Okay, this is just proper mathematical form. Different kinds of terms. We have monomials. Monomials are expressions with one term. So here we have 3x is one term. Binomial. So bi means bicycle, two wheels. Bi means two. And binomial means an expression with two terms. So here I have 4x and 5y being separated by a plus sign. Trinomials. Tricycles. Think of three wheels. Tri means three, so it's a three-term expression. Here I have 2z plus 7b and 9c. So 2z, 7b, 9c being separated by plus and minus. Okay. By the way, an expression with, in general terms, would be called a polynomial. Okay, an expression with more than one term. Okay, but specifically, we have monomials, binomials, and trinomials. You can have ones with 4 terms, 5 terms, etc. Collecting like terms. So what are like terms? So like terms are very, very important to understand. Okay, like terms have to have the same variable, and they have to have the same exponent. So when I look at 3y and 8y, I'm looking at two terms, and these are like terms. Why? Because they have the same variable, and there's only one exponent to this variable, 1. So 1y here, 1y here. Okay. What about this one? Y squared and y cubed. Well, these are not like terms. And the reason why is because y squared is y times y, and y cubed is y times y times y. Okay, I can't combine these in any meaningful way. Okay, but I can combine like terms. So, for example, I can add or subtract. When you say combine, you can mean adding or subtracting them, and you can only add or subtract the terms that are like terms. How do we do that? Well, we add their numerical coefficients. So I can add 3 and the 5 in front of these y's. So I have 3 y's and I have 5 y's together. When I add them, I get 8 y's, right? So 3 plus 5 is equal to 8. Okay, so when you add them, don't forget your variable. So 3y plus 5y equals 8y. All you're doing is you're adding the coefficients to get your result. Example number 2, subtracting like terms. So I have an a and I have an a, so I can subtract the coefficients. So 2a minus 5a. So 2 minus 5 is going to give me negative 3a. Okay, so my answer is negative 3a. Now what if your expression has a bunch of different terms? We look at the like terms here. So 3x squared and x squared are like terms. So you can combine those two. So 3x squared minus x squared. And you take the minus 5x and the 4x, you put those two together. Okay. And when you're combining like terms, you have to add their coefficients. Now if you don't see a number in front of one of your terms, your variables, then you assume it is 1. It is automatic. Okay, we don't write 1 all the time, but there's always an invisible 1 in front of that variable. So I subtract the coefficients 3 and 1, and I get 2. And don't forget to write your x squared. Okay. And then 5 and the 4, minus 5 and plus 4 gives me minus 1. And don't forget to write your variable x. Okay, the x's don't disappear, x squares don't disappear, you have to keep writing those variables in there. Okay, so again, you don't need to write the 1. You can just simplify this by saying 2x squared minus x. Okay, the fact that there's a single x here means there's a coefficient of 1, and I don't need to write it. Okay, so that is our quick lesson on simple algebra and the language we use.